I'm Joshua Bardwell, and you're going to learn something today. I got a build video for you today, folks. Whole quadcopter, start to finish, one video. But it's not just any build video. This is a pretty special one for me. When I sit down to build, a lot of the time, most of the time, I'm not building the parts that I would do in just a really high output for that reason. The other accessory, and a little bit more of a slower and more reflective manner. I did not record any voiceover while I was doing the build. So you can see me here cutting them with just a couple millimeters past the pad. Next, I'm going to strip the wires, and I do use my diagonal cutters for stripping the wires. I don't have a fancy wire cutter. My goal is to strip back about, to fix that, is to get some flux, some liquid flux, put it on the joint and reflow the joint. That'll usually fix the solder that I like to use where the nylon standoffs broke. Then that is a case where maybe you would have broke your flight controller or your ESC instead. The other way of doing it, using a short screw and then nylon male to female standoffs, that is less likely to break the electronics, but if you ever break one of those standoffs, then you're going to have sort of the flight controller flopping around, and that's safe without wasted space. It also gives some room to run wires. If you the CL Racing LED strips on the arms, I'm going to need an extra section of wire to connect the ESC to the motors. And here I'm tinning the inner length of wire between 14 and 12 gauge. So 12 gauge is just that much harder to work with. The forceps against the positive pad, which definitely helps everything stay steady. Now you can see that the whole joint has not flowed here. It's a flight controller down that you don't pinch the wires in any way. I like to run the wires underneath because it keeps them out of the way and leaves me room for soldering. But And go ahead and press that down, make sure it doesn't pinch. And I'm also going to go back through and I'm going to kind of make sure that now that the flight controller is on top, remember I kept those standoff screws loose? Here, let me get a closer look for you. I'm going to sort of pinch the ESC down so it binds the M3 nut. And now is the time when I'm going to tighten up those stack screws and get the last little bit of slack out of there now that the flight controller is on there and I don't need that little bit of wiggle to help it get on there more easily. I'm also going to come back in here with my hemostat or forceps, I don't know which it is, and tighten down this spacer so that it's holding the ESC securely. There you go. I like to tighten everything down after everything is on the stack because, again, if the screws are not perfectly perpendicular, and they seldom are, getting a board on can be really tricky. You have to really jam it down there, and it feels like I'm putting a lot of stress on the flight controller if I tighten the screws down early in the process. At this point in the build, I usually do not put the M3 nylon screws on top of the flight controller because if I do, I will melt them with my soldering iron as I'm soldering it up. But for the Kakute, these two screws on the right side are well away from any soldering, so I'm going to go ahead and put these screws on and tighten them down to hold it in place while I'm working with the board. And I'm no risk of melting it with a soldering iron because all the soldering is going to be on the left side of the board. For installing the XT60 connector, the process of preparing the wires is the same as you did when you soldered them to the flight controller. Strip, get a good hot iron, tin the crap out of them to get it full of computer, and I use the Betaflight motor test function. I use the motors tab to test that all 4 of the motors spin, and don't worry about motor direction or anything, but just make sure that you don't have a smoked DSC or something dumb like that. Also, isn't that race wire cool? The next thing I'm doing is I'm mounting the real pit board using a piece of VHB, very high bond tape. This is a really good tape for this kind of application. I'm mounting it to the blue light will go out. So again, the sequence that you want is press the button until the blue light comes on one time, then do it again, then do it for 30 seconds, and then do it one more time to exit the setup mode. And now the Unify is unlocked. If you need to, go back and watch the video and you can see it happen again. Now I'm going to remove some wires from this header because I'm not using all of them. The one I'm going to remove is the green audio wire because I don't fly with a microphone. If you fly with a microphone, it would get hooked up to this audio wire. Then I'm also going to remove the 5-volt output and the extra ground wire, which are designed for if you were using the Unify on like a fixed wing where you didn't have a flight controller, this would be where you plug the camera in. Power from the camera would come from the Unify. I'm not using that, so I'm going to remove the orange and the adjacent black wire. I'm also going to cut off this JR connector, JST connector. I don't remember the name of it. Obviously, we're going to direct solder the flight controller. The Unify is going to get power from the B+. That's the upper rightmost pad on the Kakute. That's VBAT. And I'm just using the spare orange wire that I cut out of the Unify's header for the camera 5-volt out. I'm going to use that to run power to the real pit. The technique that I like to use when soldering to these through holes is to just tin the pad and then sort of let it flow and kind of stick the wire down through and let it solidify around it. The traditional way of soldering through holes is to stick the wire through and solder from the backside, but you can obviously see why that would be not really very feasible in a situation like this. And we're going to do ground, and again I'm using the spare wire that I removed from the Unify's wire harness. And just to keep things neat, I'm going to give these guys some twists. I always like to twist my wires to kind of keep them neat. And let's see where these are going to go. They're going over to the real pit. Next we'll do video, which goes to the VO pad, video out, which is just below the B+ pad, as you can see here. And we'll solder a yellow wire there. The white wire from the Unify plug harness is going to go to a UART for smart audio. You can see me sort of feeding it up through and twisting it around here. I'm not sure if there might be an easier way to do this to keep it just, yeah, you just got to solder and twist and just make everything nice. Now I'm going to use T1 here for smart audio, UART1 transmit. That's where the white wire is going to go. It's a little confusing on the Kakute because the labels are to the lower left of the pad that they're labeling. So there might be some confusion as to which one T1 is. T1 is to the upper right of the label T1. And you can see here I've failed to push the wire through, so I just solder it on top. Who cares? It's not a big deal. It'll be fine. Just pull everything snug here. Oh, very nice, very nice. What I'm doing here is twisting together the two ground wires, the one coming from the Kakute ground, which is just to the left of B+, the one going to the Unify. Both the real pit and the Unify need to have ground, so we're going to twist these wires together and then solder them to the real pit. Yeah, hopefully that makes sense. Now what you see me about to do here is a very advanced move. Soldering over the board like this, if you do this, be careful not to drop a blob of solder on your flight controller or burn that ribbon cable with your soldering iron. I've done it. So just put something down to protect it if you really need to. So now we got these two ground wires twisted together, and get your head out of the way, Joshua. Figure out where it needs to go. Oh, but wait. You see, I've just figured out that I'm going to need to solder to this flight controller signal pad, and if I do that after I do the grounds are going to be in the way. So I'm going to do this one first. Again, I'm just using a spare wire, one of the wires that I cut out of the Unifier's wire harness. This green wire is going to go from the FC pad on the real pit to the M5 motor 5 pad on the Kakute. But real quick, we're going to finish up this ground joint right here. And the red wire from the Unify to the VTX Plus pad on the real pit. Good, perfect. And here is the Unify wire harness and plug wired up to the rail pit. Just give it some twists to keep everything neat. We still have one more connection to do on the rail pit, which is the signal wire, the green signal wire to M5. We haven't done that yet. Just figuring out how tight I want that. And there we go. Green wire from the FC pad on the rail pit to motor 5 M5 on the Kakute. Crossfire Nano receiver. It's been tinned, and I'm going to solder on the wires.
I have a radio.
first time, but I didn't like some of these joints. So I'm going back to clean them up and just reflow them just slightly. Now I've installed the antenna, and what I like to do is fold the antenna back across the body of the receiver. Make sure you see it's not quite straight back. Don't get it jammed so it's going to want to pop off against some little chip or component, and definitely don't cover up the LEDs or the bind button. But I like to fold it back over, and then this stuff that you see me using is called Kapton tape, Kapton. There's a link to it on my Ultimate FPV shopping list in the supplies section. I like to use that instead of heat shrink because I just find it easier to apply. It's thinner than heat shrink, and it's it's just easy to use. I just like Kapton tape. So you can see by folding the antenna back over the body of the receiver, it helps keep that UFL just a little more secure. Of course, if I have to change the antenna, then it's going to be annoying. I'm going to have to cut this stuff off, but that's the way I like to do it. For soldering up the Crossfire receiver, we're going to use these pads, ground, lower left, 5 volts, diagonally up and to the right from there, and then UART 4, RX, and TX. Ground, five volts. It might have been smarter to do these top down. I don't know. Either way. Ground, 5 volts. TX, and make sure that goes to the RX pad on the Crossfire receiver. So that's going to be IO2, the last one near the edge. RX goes to TX, and TX goes to RX. And here goes the RX, which goes to TX on the Crossfire. See? Yeah, make sure you get that right. And we'll give the Crossfire receiver some twists to take up the slack in its wires as well. Next.
So in today's video, we're going to be taking a look at an absolute future-proof flight controller. And what do I mean by that? Well, if we flip it over, we have the big F7, which is the more powerful, or not more powerful, one just has more memory. We have a barometer right here. We have SD card expansion. SC right here in the place. We have the wires would have to include, for example, the current sensing. It will be connected. And then all you have to worry about is a couple things. For example, camera, VTX, and receiver. And if you wanted some other things also, we're going to cover right now. So this is supposed to be installed in your quadcopter like so, with the arrow pointing forward. So the camera of your quadcopter would be right here. Now let's start with the camera. So if you wanted to install a camera, obviously you're going to have to, if you're using an FPV drone, it would go up here. We have ground, which would be the black wire from the camera, 5 volt, which would be the red wire from the camera. VI is video input, which is the yellow wire, because the yellow wire video input would come from the camera. So the video is coming from the camera, go to the video input, go through the board, go through this little guy right here, and then it'll pop out through the video output. And the reason why it goes to this chip here, and what that does is it puts an on-screen display. So it puts a lot of information on your video feed, like battery voltage, your current reading, your GPS location, where you are located from the place you took off, depending on what you put, what sensors and what you're using, your speed. So that's the reason why we route our cameras through the flight controller instead of a direct connection. So this is where you'd want to actually do that if you need that information. That information is actually very, very important. So next down the line, we'd want to do the VTX. Now the VTX is very important because in this world, there's 2 types of VTXs in my opinion. I call them the 5 volt VTXs and the battery volt VTXs. So if you have a battery voltage VTX, it will tell you that the power input is from 7 volts and above. That's a battery voltage. And if you have a small one that says 5 volt, then you're going to have to go to a 5 volt pad. So if you're using a battery voltage video transmitter, what you'd want to do is you're going to put the black wire to your VTX right here. Then you're going to want to put the red wire right here from your VTX. Then you're going to put the yellow wire right here on the video output. So the B plus here means the battery voltage. And if you had a 5 volt VTX, then the red wire would not connect here, and you'd want to find another 5 volt pad. You can go ahead and mix it up with the cameras right here. That'll be fine also if there's nothing close by. You can also grab a 5 volt from down here if you wanted to. So that'll also work. So now we want to connect our receiver. Now, whether you're using iBus, Spectrum, or S-Bus, they'll connect exactly in the same place, but some might have different voltages. And let's cover that. So where you want to connect your receiver is going to be in this area right here. And why is that? Well, it's because they give us some power out here. And they give us a 3.3 volt and a 5 volt. I'll explain that in a bit here. So if you're using S-Bus, which is FR Sky, then what you'd want to do is you're going to take the black wire, which is ground, you would connect it right here Then you're going to take the red wire, which is the 5-volt, connect it right here. And then you're going to want to connect the S bus signal to the R6 right here. Very important. Right. Actually, it's not really important, but the R is important. You can connect it on any R you want. And